Hi, welcome to Precalculus. The topic today is proving trigonometric identities using double angle identities, problem type 2. So this is a continuation of the previous lecture. We have some slightly more sophisticated identities to prove using double angle identities. So how do we think about these type of problems? Well, secant of 2x, that's where that 2 is indicative of this double angle. We rarely work with this type of functions directly. What is more familiar to us is identities involving sine and cosine. So we can think about secant of 2x as a 1 over cosine of 2x. Okay, so that's where our double angle identities come in. We didn't have many identities involving secant, cosecant, or cotangent, and so on. Best bet is to convert things to the familiar functions, either sine and cosine, or perhaps involving tangents, and so on. So in this case, what is it that we are going to do? So again, we are going to write on paper and have a strategy and then come here and type it in. Let's see. So let's go to paper and so over there we had what we had tangent and cotangent over cotangent minus tangent, and we want to show this is same as secant of 2x. So one idea is to use the ratio identity. So tangent is sine over cosine, cotangent is cosine over sine. So these are quotient. Denominator cosine over sine minus sine over cosine. Now what? Now take everything and multiply by the common denominator, which is sine x, cosine x, sine x, cosine x. So this is just algebra. What does it do? You get sine square of x plus cosine square of x. Is that right? Because when I multiply this by that, cosines cancel and I get sine square. When I multiply this with this fraction, sines cancel and cosine gets squared. In the denominator, I get cosine square of x minus sine square of x. So who is this? Pythagorean identity? That is 1. Who is this? This is cosine of 2x, and that's the double angle identity. And who's this? This is secant of 2x, and that is what the ratio, what's it called, ratio identity or something like that. Okay, now let's go type it in. So we got to the, so this is the rabbit, and this is the carrot, and here is the maze. So here is the maze that you are supposed to take the rabbit to the carrot. So I'm sure you can do it, just needs a bit of practice. Let's go ahead and type this thing in. So I need a fraction. In that I need a fraction. Next to it I need another fraction. Denominator I need a fraction, and then next to it I need another fraction. Now I go fill this up. Cotangent was what? Cosine of x, and this was sine of x, and this was sine of x, and this was cosine of x, and we repeat cosine of x. Sorry, sine of x, sine of x, cosine of x. So let's see. All we did was the quotient identities. Is that okay? Yes, it was okay. Now we multiply with sine x, cosine x. So let's see if we can go through in one stroke, or would this offer give us a bit of a headache. So here I have cosine square of x, and then minus sine square of x. So in doing that, we just did algebra. We multiplied everything by sine x, cosine x. Let's see if that's okay. Yes. The numerator is just 1. Numerator is just 1. I don't simplify denominator because that's a different rule. That's a different rule, and then suffer gets, yeah, that means sine square of x. So what did I do? I did Pythagorean. Then I have 1 over denominator is cosine of 2x. We haven't seen that often, but it's a basic double angle identity. Is that so? Yes. 1 over cosine is secant of 2x. Again, to be correct, this needs a parenthesis. So this is a bit of an issue when you go to other software. They might give you a bit of a runaround if you do that. 1 over cosine is secant. That's called the reciprocal. And then we are done. Let's try another one. So go through 10 of them. Try to do each one in under 3 or 4 minutes. That is getting you ready for calculus. So here is another one. Sine of 2x over 1 minus cosine of 2x. We want to show that this is same as cotangent of x. Let's go on paper to see what's happening here. Sine of 2x over so what did we have? I forgot. We had sine of 2x over 1 minus cosine of 2x. Sine of 2x over 1 minus cosine of 2x. And we want to show what? We want to show this is equal to cotangent of x. This is essentially that double angle identity that we had for tangent. This is essentially the same thing. So not unexpected outcome, but we are going to go, your software wants you go from left to right. That's just a convention here. Sine of 2x, what do we know? That is 2 sine x cosine x. So that is the double angle identity. 1 minus cosine of 2x. Now for cosine, we have 3 formulas. Which one of them is going to rescue me? Well, I want to get rid of this 1, and I just want to divide cosine by sine. So instead of cosine of 2x, you have to kind of like playing a chess, seeing a couple of moves ahead of you. What equivalent value of cosine of 2x should I put here? The one that is good is 2 sine square of x. Why? Because my 1's cancel, 2's cancel, sines cancel. I have cosine over sine, which is just cotangent. So here it is, 2 sine x cosine of x. This is 2 sine square of x. By algebra, this is cosine of x over sine of x, and that is cotangent of x. So this is also double angle. This is algebra. This is again algebra. And this is the quotient identity. Okay, let's see if this works out. So I have fraction 2 sine x cosine x. Now let me tempt fate and do both of these at the same time. So these are both double angle. Let's see, doing them all at the same time, would that be okay with you? Let's see. Yes. Okay. Now 2 sine x cosine x, and then we subtract the denominator 2 sine square of x. What did I do? Just did algebra. Really just arithmetic. So now that is another algebra. Cosine x over sine x, still algebra. So probably we could have gone from the previous two algebras. So from here I probably could jump to this, skip the intermediate stage, and the software will not fault me. This is cotangent of x, so cotangent of x, and that is the quotient rule, and so on. So these identities are not that hard. Again, go on paper, find a strategy, think a couple of steps ahead of where you are to see how to maneuver yourself to the final destination. It's one level higher than other kind of trick problems we had. This is like a strategy you need to come up with in every problem. So it's not like solving an equation and plugging numbers and such. Rather, you want to find your path through a set of identities to reach a destination. Okay, so until next time, good luck and God bless.